Hi, and welcome back. We're now going to go into using built-in functions and libraries within Foundations Python. My name is Dennis. Let's go ahead and get started. Our learning objectives for today include using common functions and libraries to make basic tasks easier inside versus creating them from scratch. We're also going to be able to import packages within using the built-in tools, and then monitor performance and memory consumption using a tracing and test case tools against different examples. First, Python using built-in functions. Python is extremely powerful and a versatile programming language with lots of key ingredients and features that make life easier for most programmers. Let's go ahead and get started. So, what did I say in the last module? I said, if I can get my pen going, read the documentation. Right? It's one of the most important things you can do as a developer. The help function can say, help me with set function. So if I didn't know how to use print, for instance, I go help, use the help function, put in the parentheses, print, and then I get information about how to use it. There's also third-party resources such as w3schools.com/Python, which also give you interactive help guidance and examples. Finally, and not least, is the docs.python.org, the official documentation for Python 3. Always check the documentation. If anything else, Google it, search for it. I'm sure there's someone that's been out there, someone that's had the same difficulty. So why reinvent the wheel when someone else figured it out for you, either through additional modules or perhaps using a third-party resource to help you find clues to how to get your program running up and go into what you're looking for. Saves many times for understanding how to utilize a function, troubleshooting errors, for instance, and other workarounds as necessary. Now, just to reiterate and give you a reminder, Python math operators. Again, built-in functions, plus, minus, multiplication. You don't have to rewrite them yourselves. You don't have to teach a computer how to actually multiply something. It's all built in for you. It's part of the abstraction that high-level programming languages usually provide. Here's an example of some math operators. Now in here, the screen may look a little bit different. I'm using AWS Cloud Shell, which is free. Includes Python modules, so if you want to get started with your AWS console account, go ahead and sign in to do so, or use REPL. Here in this case, I'm using all of them. So multiplication, division, modulation, modulus, and then ultimately down here, something a little bit more complicated, which is 12 divided by 3 to the power of 2. Now I get 1.3, which is a huge floating precision, essentially precision number. Some other common functions, something that we didn't necessarily cover in the last one. We went over it quickly with a brief, here's a table of functions. Here's how you would use them. Start off with a little bit more. We have examples like the maximum, the minimum, and the sum of something. You saw some last time. But here's some other ones. Like I showed in the demonstration, type. What about range? How do I create a range of numbers? Well, to do so, use the range function and specify at minimum the lower bound and the upper bound. And then you can provide information. A range is a data type or data construct itself. And then you'll also have a type, and that type is class range. But you have to iterate over it. So, such as a for loop or something of that nature, it just has a construct of saying 1 through 9 in this case. Now, there's another one called list. I could say 1, 4, 7, 10, and print that list. Remember that list uses brackets, right? Square brackets. If I have a list and say, hey, what is the minimum in that list? Then, well, the minimum value is 1. Our maximum value is the same thing in my range, as well as the minimum value in that range. Now, I just said something erroneous here, and here's why. This is on purpose. Remember when you gave me this weird look when I said my range, even though I said 1 through 10, but I actually said 9? Here's why. Maximum of a range is always 1 less than the upper bound that you provide. However, in a list, the list is an absolute value, so you actually provide that including upper bound. Keep that in mind as you're programming different things. And of course, setting my range of 1 through 9 is different from summing my range in a list, which skips numbers, which equals 22. Right? So ultimately, we have strings, we have lists, we have integers, we have floats. We have all that we need, right? Maybe not. Let's look at how to actually utilize different types, right? And additional functions. So we have the length function. We saw type a few times. We saw list, maybe not used as a list, but actually using square quotes, square brackets actually. But we've seen integer, we've seen float. We haven't seen string yet. String is just a string of characters, something that you and I would understand. So if you put something in quotes like the number 10, that's a string. I'm just saying, hey, Dennis, that's 10. Nothing to be calculated. However, if I say a equals 10 and put it in the Python, it's going to calculate it as an integer. How do we know? Well, let's take a look at it here. Start from the top. This is a really cool class. My string equals with double quotes or single quotes. And again, using the type function, we determine it's my string. Here's the cool part. I can measure how many characters, including spaces, that whole line is, which is 27. Now, what about numbers in my string? Well, I can put numbers in there, sure. 10, 100, 1, and it's still a string. The minimum numbers in my string, the minimum, which is any value, which is none, which is actually a space. The length of my string is actually 10 characters, not because it's actually 10, because this is 10 characters long, including the spaces, right? Kind of a nice, tricky question for you. How about what we just talked about? 10 in quotes, is it just a number? Oh, it's actually a string. So if I'm trying to multiply the string 10 times 10, I'm actually going to get 10 read out 10 times. However, if I just say 10 times 10, I get 100, and it's actually an integer. Take a moment to pause and think about what you see at the top and at the bottom of the screen. Try to make sure you have a distinction between strings, integers, floats, and lists before we continue. That's okay, I'll wait. Pause the video and make sure that you have these concepts memorized. Okay, let's go into a little bit something more interesting. You can't just keep putting static information inside a program. At some point, a user is going to want to do something with it, interact with it directly. So, with that in mind, let's go ahead and create our first input program. Now, you saw in the previous module that I alluded to that you use the input function to actually take input from a user at runtime. You use print to actually print it back out to standing out and capture that information in details. So, in this case, I have a more simple example than saying Dennis is a range of instructor scores. I print a statement saying do something. Now I'm saying enter my name. I save it into the user input variable and then print the user input variable, because the interesting about every input as a user, even if I put 10, it's always going to be interpreted as a string. So instead of putting Dennis, if I were to put 10, it would output 10 right here. Of course, I wouldn't be able to calculate anything with it because it's a string. How about reading a file? Well, that's something that Python can do natively in its own built-in libraries as well. But the interesting about a file is that we have to define it by opening it and closing it. So I want to open a file. We'll say user-input.txt, and that's the thing I want. Right? Let's say it's just whatever you put in your operating system. Use the open function, and then a second parameter here is just to read it. R for read, W for write. I then want to actually read it into a string. So not just being an object inside Python inside memory, but read it into a string. I can read the entire contents using a .read method. So I'll just say, hey, everything in my file object, form a read function right there. And if I do a type, you might actually get the information back that you're looking for. We'll close the file handle, which is always the best practice, so you don't leave it open and a lock on it inside the operating system. Now, let's reopen it again. And this time, we're going to actually read line by lines by saying read lines. So we're actually streaming it inside memory as opposed to reading the entire item as a huge plot. course, we print this file and as well as the type and see what happens. All right, well, let's go ahead and take a look at what that means. We have our program to the left that we just created, and now we have our ingestion to the right. Now, what's our ingestion? Well, there's our ingestion right here. We can use the echo statements to append different items. How to sort XYZ, 1, 2, 3, ABC, and foo. Now we go ahead and create and run our program, which is up here in the runtime. It's reading line by line the entire contents of the file. Now that's .read, right? That is right here. Oopsie. Get that right back here, and somehow I didn't be able to erase everything on the slide on mine. Let's go back. Sorry about that. Then there we go. So that read that you see right here, that's what it looks like. Ah, that is not the right one here. Our read right here is what it looks like. Our read lines, however, turns into a list. So it actually allows you to iterate. Right? It allows you to iterate over that list. Now, there's something interesting here. You see this /n means new line for return carriage. So as you append new lines in the file, we're using the double redirector. That's what you're doing. You're actually creating an additional new line. Something that you don't see here because it's a hidden character. Now let's go back. Let's iterate over that list. So we have what we have here is a modification. So I've commented everything out up here. Pay attention to what's going on down here. Let's go ahead and read the same user input, use read lines by itself, and then sort the lines using what's called sorted. Right? Sorted. Then print the sorted lines together. So this is what's happening here. It's sorted. And that's what's going on right here. Right? This is what's going on right here. However, I don't want it necessarily in a list format, right? Because as a human, that's hard to read. I wanted something line by line. So instead of using a list format, I have to iterate. When I say iterate, now I'm saying for every element in that list, which means element 0, 1, 2, 3, and 4, right? For those 5, right? 0 to 5 because 0 to 4 because humans count at 1, computers start at 0. For all items in there, print the line out. Now I don't have a nasty new line character. It's all right there, just like I did using .read. Now, why would you use a line by line in the stream versus read everything when it's more complicated? Let's say you have a much larger file, one that takes up multiple gigabytes. You don't need that all in memory, so you actually need to iterate over it so it can actually make room in memory and not blow up your computer. Not literally, but you know what I mean. To conserve more consumption and resources, utilize iterations and string something as opposed to put everything inside memory. Now, data type convergence. We talked a little bit about this. We saw this previously. Now, I keep bringing this back up for a reason because I want you to remember. I want you to be able to recognize and understand what you need to do here. So let's look at integers and floats, strings and lists. 2 separate types, but 4 separate data type conversions. Well, I should say 2 separate categories of comparison. Let's start from the top again. 10, it's an integer. Multiply by 2 by another integer, and it will always remain an integer. If you change the variable, right, we're overriding variable at this point, to a string of 10, it's going to print 10 twice. Now, let's change this back into an integer, right? We have an integer of my variable, it's still 10, but we can change string back to an integer using the integer integer function. Multiplied by 2, we get 20 again. What if I turn it into a float? Same thing. It becomes a decimal at that point. More precision, which is why it's called a float. What's next on our list? Well, let's look at a list. We saw strings already. Now we have a list full of different types of variables. 10 as a string, 10 as an integer, 10 as a float, and yet another string here saying end of list. How many elements did you see here? 1, 2, 3, and 4 on computer terms, 0 to 3. We have a type of my list, and how we reference each element of this list right here, we have the actual brackets at the end of my list reference. 0 for the first one, 3 for the last one, and we can always go type here against each element to have a verification of our interpreted inputs. So, operator refreshers. You saw this example before. I'll show it to you again just so you have a clear understanding. Again, we're overlapping our knowledge, getting nice reviews together. Logical ands, ors, nots, trues, and false, as well as arithmetic based, right? Here's an example of arithmetic based, but it's creating a true or false condition. And we're using ands as part of our operators for comparison. So what I want you to pick up here is that you can actually use decisions based on multiple comparison requirements. If you're properly evaluating something, you'll get to the destination that you're looking for, such as the if-else condition. And I have a comparison of comparison 1 and comparison 2 to make this a true statement. Get above here, which means I have to meet the qualifications of being over 5, but 10 or below. Take a moment to pause here. Remember what we did last time. Try it out for yourself if you need to punch it in. Okay, how about some other refreshers? Well, we have a list. Now we have conditional if-elses and some loops now. We saw a little bit about this earlier when we were actually reading from a file as a stream. Let's take a little bit deeper dive and a closer look at this. We have a list of my song words, which is this song repeats, 3 separate words, and we have a counter. We're going to take the length, which is 3, and add 1 to it, right? Actually, not actually 3 in terms of computer terms, but 2 actually in computer terms, because this is 0, 1, and 2. So I add the 1, so in human terms, we're saying counter is now integer of 3. Now, for every word, which is just an iteration, or you guys say I, X, it doesn't matter. For every element in my song words, that list, that this song repeats, print that word. Now, take the counter and then reduce it by 1. And keep looping until what? Well, if the counter equals 0 or less than 2, keep printing those words and repeating itself. Does it really repeat? Let's think about that. Try it out for yourself. Pause the video. All right. Hopefully you had a nice iteration into that. Pun intended. For now, let's go ahead and take a quick break. We'll see you back from the break and then go into our next item here. All right, welcome back from the break. Hope it was a good one. Let's go into some common modules. Beyond the built-in operations and functions, there's some modules that are not necessarily provided for you that's part of your main built-ins, but you can import it because it's part of the Python standard installation. First, we have regular expressions. Now, if you've never seen regular expressions before, it's a way of saying, hey, I want this pattern. You could have multiple variables of that pattern or variants of it, but I define what those constraints are. So we use the RE module to accomplish this. To find an IP address, right, typically you have 4 octets of something, as you'll learn in networking, and they range from essentially 0 to 9, depending on what it is. So what is a regular expression? Well, you have regix101.com to help you out. and you also read their cheat sheets. But on top of that, let's look at what our structure actually looks like here. If you know what an IP address looks like, and it's going to have the same pattern each and every time, such as IP address here, 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 here. Notice they're all different numbers, or there's two different sets of numbers, widely different. So it could be anywhere from really 1, because 1.1.1.1.1 is an actual valid IP address. It's actually owned by Cloudflare, which is an Amazon-owned company for public DNS records. That's valid IP address as well. So what does that pattern mean, understanding the algorithm behind it? Well, in regular expression terms, we can say a digit and match 1 to 3 times in between an escaped dot 4 different groups together, and put the parentheses right here and afterwards to say 1 matching group. Now, we'll learn a little bit more about regular expressions as we go through, and you'll get more examples. I just want to see, and I want you to see and really understand that we can actually use patterns to define something. Inside the modules of Python, we have regular expressions, which is RE module. They have 3 different methods that you'll commonly use, which is find, match, and find all, depending on your use case and needs. Don't worry if this looks confusing to you. We'll have plenty of practice later on. There are some other modules in common functions. You can import matplot and numpy. You can actually take an array of numbers and plot them to create an histogram accordingly. Yes, you can actually have visuals and create them as PNG files, so you can actually have them and let them display over the web. Here we can see that we have our data set, which is completely randomized right here. Really good for data science and analytics. But we really don't have a really evenly distributed set here. So it's not an empirical or bell curve. So we might have to look at our model and see what's going on if it's lopsided. We also have the system and operating system models. So we can say, hey, do something with this file and run some commands on the computer. In this case, I have ping right here. So if I run my Python program right here, this is the output. Kind of cool. And if you're wondering why would I use Python program to run an operating system command when I could use terminal? Big question. What if you were actually trying to iterate over something like a large set of IP addresses that we have here, at the domain names? We can iterate over these and say, instead of Dennis typing in ping google.com, ping amazon.com over and over and over, I can go ahead and have a list of tens of thousands and say, hey, programmer, you do it for me, and I'll use ping still. Kind of cool. Great way to automate. Here's another way. I created a custom Scapy script using a module inside Python called Scapy. And in this, I've created what's called an ICMP. This is a security penetration testing example. I actually created a packet to actually ping instead. So instead of me using an os.popen to actually ping something, I can also go ahead and create packets with the ping commands accordingly as well if I had to, and actually take information in there. So this is an example of a security-related script. I'd like to show you guys later on. Realistically, what we have here is you can do everything. Scapy is a great way to actually make packet level custom packets and receive them over the network. Right? So it's really cool to transport data if you had to go down to the deep network layer. Another common module is the http.server. So if you need to mock something up, temporarily host something, why create a whole program for it when someone's done it for you inside a module? Simply use python-m http server, set your directory, what IP address to bind to, and the port. Now, it's important to keep in mind that as you run Python, if you're running as an administrator, you can be able to list, or it's going to run as administrator, it's going to showcase the listing of the admin level permissions. Now, also requests. Requests is also another interesting model to use. In this case, I'm actually saying use a different API, one that's public, because this is not local to me. This is actually going to grab information about an IP address and give it back to me. I'm going to take the response of using request.get of that API and print the response. Clear the string for you. So I can take the output and take the output and parse it to JSON, which is JavaScript object notation. Now I can parse what is returning me. So here's my key value pair, which is IP colon, and then the actual IP address. What if I only wanted to have one or the other? Well, to do so, I need to go and say, hey, print out only the IP address, or print out only the actual the IP itself, or the IP key. To do so, we actually have what we have here is print out v, right? Because key value right here for the left side and the right side. Print only the right side, which is going to print for me the IP address accordingly here. Notice that I can't do an output of the key IP address because it's not an actual string loadable. Okay, so as you reference a JSON output, that you need to have a key value pair, and we'll go over that more when we get into further into the actual course. For performance monitoring, we have instrumentation. It's really heavy. You have to modify your code, and in Amazon Web Services, you have AWS X-Ray. You can instrument your code by injecting different hooks in there to understand that the performance issues or debug latency items and even error messages accordingly at every function and solution in your code. That's what we call instrumentation. Now, profiling is a little bit easier, lighter. We actually want to profile things, and we'll do that as part of our hands-on lab today. Profiling takes samples as opposed to so one of every 30 calls, as opposed to all 30 calls for the pure, super accurate instrumentation. What's an example of profiling? Well, the profiling is called C profile, the capital P, to profile the performance of your actual program. In this case, I'm running main.py, and I'm going to get the first 20 lines here piped out using this, and it's saying it ran in 1.3 seconds, and these are all the calls it made accordingly. Let's get into some demos and see what this actually looks like and how we can interpret some of this stuff. We'll see you in a second. Feel free to take a break. Hi, and welcome back. Hope you had a great break. I think one of the most confusing things that students have is, what is a regular expression? How do we use regular expressions? And understanding that there's a huge power in that you can find patterns and then extract that from files or anything else inside. Let's start with regular expressions a little bit more. So let's think about email addresses. We saw IP addresses last time. Here you have a quick reference information about the characters. And so all you're doing is saying tokenizing what you want. And it really takes a little bit of practice. So we'll do one example here. And the rest of you can actually utilize regular expressions using the RE module as we move ahead inside the course. We'll also go over a couple of the other syntaxes, learn to read the code, and definitely practice on your own during the lab. So let's say we have Dennis at foo.com. We have Chow at Google.com. We'll also have student at foodbar.com, and we have 3 different things. So instead of me typing it out, and let's say we have a bunch of text in between. We have some gobbledygook in between, in the middle, and it's causing all kinds of weird issues. And for whatever reason, I can just get back in here, yep. And for whatever weird reason, it's just mixed in, right? And it's very difficult to read. And it's because maybe there's sort of corruption, who knows? So one of the interesting things is that you can say, hey, well, you may not know, Dennis, how to actually parse this. How can we get only the email addresses that we want without having to actually do anything else? Well, the first thing we want to do is, what's the common denominator? Well, we always have an @ sign that determines an email address. Is that good enough? Well, we need the beginning and the end. What helps us demarcate this? Well, this could be .NET This we dot or just to give some more texture. Well, we know the common denominator is the @ sign, so let's just use @ up, and we have it, and it says match the @ character, and we have nothing else. Okay, but don't return anything else, and we don't want that. But we do want the entire email, and we get to the left. Well, we have letters. We can always say slash lowercase. That's only the first one. If they have plus, oh, we have everything in front of it. But here's the catch. This goes from 0 to infinity. So we can actually say any non-space could be part of that. And what if we don't have a separation by space? Oh, now we have a problem. So we can always say your email address can be super long, but we can also look at RFC information. So let's do that. Let's think about this from a developer-centric standpoint. RFC compliance, email address length. A line of characters must not exceed 998, but should not be more than 78 characters long. So depending on your domain name, you can't have more than 78 characters. Now, this is not going to give us an exact precise thing, especially if you have highly disorganized information. But this can give us a good hint. Well, if our domains are somewhere in between unusual less than 20 characters, let's start with that. Start with the easier one first. Break it down. We'll say any word, character, from 1 through, we'll say 30. That looks pretty good, but we need to find the suffix too. So now we say /escape, the dot, like you saw last time for IP addresses. And usually our suffix includes 3 suffixes. So we'll say any word character between 1 and 3, or simply 3. Now we have the domain name and the @ Now let's get to the harder part. How should we define something? Well, in most cases it's hard unless you have a very specific domain email addresses. Well, what you could do is say any word character, set a plus, which could be infinite, limit it up to 20 characters. Now, in these 20 characters, now we have emails that even is not foolproof, because I could still have that as a match if I have no spaces in there. What I could say is also say I don't want any, don't match on anything that is a space. We'll just say a /s. Now, we can say that's a negate, but it's also pretty useless because we still have 1 through 20 as characters. So you won't necessarily have the most perfected regular expression, but you can get close. And from there, you can actually take it into bite-sized chunks. This expression for email addresses could actually go into the Python import for regular expression. We simply go import RE, and then we can actually utilize, let's use some sample code here. Let's find my sample code. Let's find my sample code, but we could use mine, or we could just use something else. So we'll say my my string. We'll say we'll have a string of a list, or a string by itself. We'll say something foo at foobar.com. And we'll just put 1 for the sake of just example in a minute. Now we can actually say, all right, our result is RE. Now we're going to use the .find. When we use this find iteration, we'll find all. Only use find all. And then we'll say, we'll take our pattern here. We got to put that as a string. And then we'll specify my string. Run it. And now we'll say my string, our result is what? Foodbar.com. And it provides us back into a list format. Really interesting stuff. So if I had multiple matches, each one would be a separate element inside the list. Let's say Dennis at chow.com. Run it one last time. Whoopsie, not compile. We'll say result. Now we have foo at bar.com and Dennis at chow.com. Really powerful stuff when you think about it. So that's one way to use a standard model. Let's use some other examples here. Well, how about we use our round? All right, so let's paste the sample code here. Remember this one from our presentation? What does it look like? This song sucks, this song sucks. Didn't suck last time. But we need to really create another if counter to this. Let's take this one out. Because we're decrementing it, right? And should we be able to print this? Why doesn't it repeat? Well, because we already start at 3. So if we go to 2, it'll print the word, and that's it. So we actually need to create a condition saying, hey, somewhere in between, because it only has 3 words, make sure you print the 2, because at some point, you want to iterate it over and over again. So that's why we create to get it twice, you go ahead and use the if iteration along the for loop. Let's try one more example. Pause the video, take some time to read this, and then let's figure out what this actually means. All right, did you get some time to analyze it? Before we run this, let's figure out what's going on. We have a string here, and we're going to say for the iterable, like say I or character, doesn't really matter. Every character in my string, do something. If it's uppercase, right? If it's uppercase using the string method, you can always look it up on the Python documentation, is equal to true, right? So if it's uppercase, and that is a true condition, right? This is an uppercase letter. If it's lowercase, right, this is lowercase, and if it's not, this is not an alphabetical character. So we have foo with a elite 2 zeros and then bars. Let's run. Wow, okay. So we're identifying everything correctly. 0 is on an alphabetical character. Makes sense. And we have 2 zeros in here. So we still have 2 bars. We're identifying that this is a lowercase character and uppercase characters. Notice that we don't have to have else if. We can just have simply if. So if we go down here and this matches, it's going to stop right here and go here. If the character is this match and not this match, it's going to go here and then stop here in this code context. And for everything else as a catch-all, check it out right here. It's going to not be an alphabetical character. Well, that's it for now. Let's enjoy our lab. Come to your instructor if you have any questions. Thanks for watching. We'll see you in the next module.